In this video, we're going to talk about similar polygons and how the scale factor will change based on either a length or an area. So if we're given two similar figures with a scale factor, say of A to B, then if we're asked to find the ratio of their corresponding side lengths, it would also be A to B. So we can actually write a proportion right from this information. If I have the scale factor and say one of these side lengths, I'm only missing the other, then I can very quickly find the missing side length. Perimeters, remember that is just another length. It's just the length all the way around the outside, but it's simply just another length. So it's still A to B for the ratio. If it's the area, though, that is a little different. Now, we can't just do A to B. I have to make sure that I'm paying attention to the fact that area is not a length, but it's literally the amount of space, two-dimensional space that's taken up. So I have to square A and B for my ratio. So let's go ahead and take a look at a problem where we actually go through and do this. So number one, for this problem, so we're going to read this problem in a minute. They want the ratio of the corresponding sides, the ratio of the perimeter, and the ratio of the area. So we're going to go through and we're going to fill this out to answer the two questions down here, the two fill in the blanks. So a pair of similar figures is given below. Note that the figures are not drawn to scale. They're giving you that note because they don't want you to try to take any measurements of the diagram. They want you to use the properties we just learned. So the sides BC and DE are corresponding sides. So BC and DE, the two that they have labeled, are corresponding. Use the information below to find BC in figure 1 and the area of figure 2. So with this one, you can see I have the area of figure 1, but I do not have the area of figure 2. I have the perimeter of figure 1 and the perimeter of figure 2. So I'm going to use this to find my ratio. And then I don't have the length of BC, but I do have the length of DE. So you want to find the one that's filled in. You'll have the same information for at least one of these one of these sections. So either I'll have both areas, both perimeters, or both lengths for side lengths. So since I have the perimeter, I'm going to compare the perimeter. So if I look at the ratio of A to B, I'm just going to say this is A and this is B for figure 1 and figure 2. So we're going to find lengths to compare. So A and B, I'm going to go 28 over 16. And I do want to reduce that, so you can see I'm putting that in the second section because it's my perimeter. So 28 and 16 can both reduce by 4, right? 28 divided by 4 is 7. 16 divided by 4 is 4. So my ratio is 7 to 4. Okay, so now I can use this to find my missing length for figure 1 and my missing area for figure 2. So if I come over here for my length, remember the perimeter is a length, so it's going to have the same ratio as the corresponding side length. And for this one, to find out the area, I can set up a proportion and I can do the cross multiplication. But this is already 4. So if this is 4 and I have a ratio of 7 to 4, well, this one has no choice but to be 7 because it's 7 to 4, right? So if I set up the proportion, I would still find this, but this one's a little easier because it's already one of the two numbers, and I have to have 7 to 4 for my ratio, right? So that was just a little bit of a kind of nice feature there. It filled itself in a little bit. For the areas, it's not going to quite work the same way, so I am going to have to square both of these. So you have 7 squared and 49, or 4 squared, so I get 49 and 16. So this is my ratio of my areas. I take that ratio of the sides and I square it. So now I'm going to use 49 over 16 to find my missing area. So remember, 49 is from figure 1 and 16 is from figure 2. That was what I squared with the 7 and the 4. So it's figure 1 to figure 2. So my second ratio needs to be figure 1 to figure 2. I don't want to mix those up. So figure 1, I have an area of 147. And figure 2, I don't know, so I'm just saying capital B for just a moment. And I could have done A for area. I just did B for whatever reason because I was doing A and B. So now I'm going to cross multiply because whenever I have a proportion, a ratio equaling a ratio, I cross multiply for my first simplification step. So I have 49 times B, and then I'm going to cross multiply the other direction here, and that's going to equal 16 times 147. Remember, the equal sign is still there. I'm not really changing anything. What I'm doing is I'm simplifying. I'm I'm reducing it. I don't want to say reducing it, but I'm simplifying it to the fact that I don't have my fractions anymore, right? I'm moving these denominators. So b was a denominator, but now it's being multiplied by the opposite side. 16 was a denominator, but now it's being multiplied by its opposite side, right? So I just very quickly get rid of those fractions. So now I'm going to have 49b because I get rid of the little dot. I just smush them together. And when I multiply 16 times 147, I get 2,352. So now I'm going to divide by 49 on both sides so that I can get b by itself. So 49 divided by 49 is just b because 49 by 49 cancels. And 2,352 divided by 49 is 48. So the area of figure 2 is 48 centimeters squared. Make sure you choose the correct unit. If it's a length, it would just be centimeters. If it's an area, it would be centimeters squared. All right. So that is how you use this scale factor to find missing lengths and a missing area. I hope that helped, and I'll see you in the next video.